let's go to page 444. And this is lesson 9-9. The objective of this lesson is to solve systems of linear equations in 3 variables. Okay, so system equation means you have more than one equation. And so 3 variables in this case would be usually it's x, y, z. Okay, so let's go to example 1 on page 445. When you have system equation, you want to write the equation side by side so that you have room to work underneath. Okay, so first equation is 2x plus 3y plus 2z equal to 13. And the second equation is 2y plus z equal to 1. And the third equation is z equal to 3. Okay? So to solve, this is kind of nice and easy because the variable is already, one of the variables is already given, so you can just substitute back and back. Okay, so this is already one of the answer. So you don't want to substitute into here because you got too many variables. So you want to substitute the one with only 2 variables. So substitute this into here. And when you substitute, put in parentheses, it help you to cut down mistakes. So to solve for y, you can minus 3 on both sides. So you got 2y equal to negative 2. And then you divide by 2 on each side. So you got y equal to negative 1. Okay, then once you do that, you go back one more step to here. Okay, so you got y and z, so you can substitute into here. So you got 2x plus 3 times y is negative 1. Plus 2 times z is 3 equal to 13. So work it out. So you got 2x minus 3 plus 6 equal to 13. So you got 2x minus 3 equal to 13. And then from here, let's see, plus 3. So minus 3 plus 6 is plus 3. Okay, so minus 3 on each side. So you got 2x equal to 10 divided by 2. So you got x equal to 5. Okay, so that's your x, y, z. So this is fairly easy because you can, they already give you one of the variable, and over here there's only 2 variables. So this is the basic, the easiest type of system equation. Now let's go to example 2. Okay, example 2 is going to be a little bit more complicated. So again, it's a good idea to write your equation side by side so you got room to work underneath. So equation 1 is x plus y minus 2z equal to 7. Equation 2 is negative x plus 4y plus 3z equal to 2. Equation 3 would be 2x minus 3y plus 2z equal to negative 2. Okay, now first thing you need to do is try to decide which variable to eliminate. Okay, and what you do is look at the coefficient. And usually the lowest coefficient will give you the easier one. Again, not always, but usually. So if you look at the x, coefficient is 1, negative 1, 2. Okay, the y is 1, 4, 3. So that's not good. Z, you got 2, 3, and 2. So that one is not too bad. But I'm going to go for the x. Okay, so I'm going to put this under here. Okay, so I'm going to use the equation 1 and 2. And the reason I labeled this so you can see what equation I'm using. Okay, so I'm going to put this under here. So you got negative x. Again, to eliminate, you have to make them opposite, right? Okay, so put this under here. Okay, and you add, so this will cancel out. So you got 5y plus z equal to 9. Okay, so there are three equations, so they can make 3 pairs. You can use 1 and 2, 1 and 3, or 2 and 3. Okay? So I already used 1 and 2. So what I'm going to do next is I'm going to use this 2. Okay? So I'm going to multiply this by 2. Okay? Again, I need to make the opposite, right? So first you have to decide what variable. So I decide on x. Okay? So when I decide on x, so this is already opposite. Now I'm going to make these 2 opposite. So I'm going to multiply this by 2. Okay, so I get negative 2x plus 8y plus 6z equal to 4. Then I'm gonna put this under here. So I'm using the 2 and the 3. So put it over here. And so the reason for that, I just kind of save the space of it in case I need it. So I got 2x minus 3y plus 2z equal to negative 2. So when I add, this cancel out. Okay, so I got 5y plus 8z equal to 2. Okay, so you go from 3 equations, 3 variables, down to 2 equations, 2 variables. Okay, and you just repeat the process. So now you have to decide which variable you're going to eliminate next. So what I'm going to do is I'm going to eliminate the y. Since these are 5y, this is 5y. So I'm going to eliminate these. Okay. So this one is not too bad. If you're going to eliminate the z, that's fine. So if you're going to eliminate the y, you multiply this by negative 1. If you're going to eliminate the z, you multiply by negative 8. And I don't like that because the number is going to get big. Okay, so I'm going to multiply by negative 1. Okay, I'm going to get negative 5y minus z equal to negative 9. And I'm going to put this under here. Okay, I usually try to move the one with a positive. That way I can reserve the space underneath to do more solving. So I'm going to put this under here. Okay, so I'm going to put some arrow over here so you can see where this equation came from. So I get 5y plus 8z equal to 2. When I add, this cancel out. So I get 7z equal to negative 7. Divide by 7, divide by 7. So z equal to negative 1. Okay? Okay, so now once I solve for one of the variable, I need to go backward one step. Okay? Now don't go all the way back to here. Okay? You need to go back. So you got one variable, so you have to go back to the one with the 2 variable. So you can use this one or this one, either one. Okay? Now you want to choose the easiest equation, so I'm going to use this one here. It seems that this is the easiest one. So 5y plus z equal to 9. So I'm going to substitute. So I got 5y plus negative 1 equal to 9. So plus 1 on both sides. So I got 5y equal to 10 divided by 5 divided by 5. So I got y equal to 2. Okay. Okay, so again, start with one variable. I go back to 2 variables. Now I can go back to 3 variables. Okay. And again, you can choose the easiest equation. So I need to look for x. And normally I don't like the ones that allow a negative or high coefficient. So I'm going to use equation 1. Okay, I'm going to use equation 1. I got x plus y minus 2z equal to 7. So I'm going to substitute. So I got x plus, again, whenever you substitute, always put in parentheses. That way you can keep track of what is being substituted. Okay. Okay, then work it out. So you got x plus 2 equal to 7. So I'm going to minus 4 on both sides. So I got x equal to 3. Okay, and that's it. Now you can write it this way, or you can write it in a coordinate form. But when you write in the coordinate form, you have to watch your x, y, z. So you're going to get 3. So that's x, y, z. Okay. So you can just leave it x, y, z this way, or you can just do it this way. Either way. Okay. Okay. So let's go to the example 3. Okay, solve the equation. So you got equation 1. You got x minus 2y minus z equal to negative 1. Equation 2, you got 2x minus y plus z equal to 1. Equation 3, you get x plus 4y plus 5z equal to 5. Okay, so again, first you need to figure out what variable you want to eliminate. So let's take a look. So you got 1, 2, 1, so that's not bad. 2, 1, 4. You got 1, 1, 5. Okay, so I'm going to eliminate the x because x is 1, 1, 2. The z is 1, 1, 5. Okay. Okay. So let's see. Okay, so let's go ahead and eliminate. You know what? The z is already opposite. Let's go and do the z because probably it'll be easier because this is already opposite. Okay, so I'm going to put this under here. So equation 1 and 2. So put this under here. So you got 2x. So again, we're going to do the z. Okay, we're going to eliminate the z. Okay, put this underneath here. So you got 2x minus y plus z equal to 1. Okay, so when you add, you're going to get 3x. This will cancel out. So it'll be minus 3y equal to 0. And from here, you can lower the number by divide by everything by 3. Right? All these are multiple of 3. So you want to lower the number as you can. So you got x minus y equal to 0. Okay, so keep that on the side. Okay, now over here, okay, I'm going to do the z. So I'm going to multiply this by negative, okay, let's go and multiply this by negative 5. Okay, so I get negative 10x plus 5y minus 5z equal to negative 5. Okay, and I'm going to put this equation down here. So I get x plus 4y plus 5z equal to 5. When I add, I get negative 9x plus 9y equal to 0. And again, I'm going to lower my number, so I'm going to divide everything by negative 9 because I don't like the negative in front. So I'm going to get x minus y equal to 0. Okay, so now notice over here I get two identical equations. So in this case, this system of equation is dependent. So you're going to get infinite number of answers. Okay. So you can just try. So in this case, you're going to have x equal to y. So it's going to work as long as x equal to y. Okay. And so you don't have to solve it. So this is dependent. Okay, so in this case, to solve for z, you have to make x equal to y. So for example, you can let y equal to 0, 0, for example. So if you let y, and so again, this one, notice, you move over, you're going to get x equal to y. You're going to get x equal to y. Okay, so it's going to work as long as x equal to y. So to find z, you can use this equation over here. So you got 2x minus y plus z equal to 1. So again, you can try let y equal to any number, and easier number would be 0, right? So if I let y equal to 0, x equal to 0, then I get z equal to 1. So one of the possible answers would be 0, 0, 1. Okay. Now if you let y equal to x, if you let x equal to 1, y equal to 1, okay, then you're going to get 2 times 1 minus 1 plus z equal to 1. Okay, so you're going to get 1 plus z equal to 1, so z equal to 0. So another possible answer would be 1, 1, 0. So again, there are infinite number of answers. So depends on what value you put in, you're going to get different answers. Okay, and the reason because you got two of the same equation, and they are good. So therefore, you're going to get dependent equation, system of equation. Okay. Now, if you get something that contradicts each other, then will be no solution.